Previously shared. Who joined the call? Someone joined the call, right? Who is Diksha Priya? Do you know? Okay. Screen is being shared, right? Yeah. Okay. So today's topic, like I said, will cover joins. So I guess I got feedback from a few students that yesterday's class also was a bit too much. So I'll take care of that. I mean, it's fine that you don't understand. I mean, you didn't understand few topics of yesterday's class because there were new formulas which we introduced it, right? And if you haven't used Excel or even if you don't have any understanding of prior experience on data handling, then yes, it would be a little bit too much, right? But today's topic is not related to yesterday's topic. So even if you don't understand anything from yesterday's topic, I first of all, this is not related. Second, I will again record that session and share it with you guys. Okay, that will help. So before we start the joining, there are three important concepts which you guys should know in order to why we do joinings or how we do joinings, and yeah, the things which we should know before doing any joins, right? First thing is why. What is the need of joining? Why I cannot bring all of my data into one single table? So I said like there was customer table, there was order table, there was shipping ID table, right? Why can't I bring all of that data into one single table? Why there are need to be different tables, right? There can be only one table, which is like very long table, right? And I can do the query on that. Then there is no need to join. There's no need of join keyword only then in SQL. Why those standards are being put, right? You can remove that join only from the SQL, right? The reason being is the data normalization. So, I mean, by definition, it's fine. I mean, even if I read the definition, it will be still be ambiguous. But reason why, what is normalization? Normalization is done to eliminate redundant data, minimize errors and anomalies, simplify queries. These three things, I know these, even after reading this thing, it will still be an anomaly or it is still ambiguous, like what is data normalization. But in order to understand it in simple terms, it says the basic purpose of normalization is to say that each and every table has a distinct purpose, right? There is a reason why customer table will have only customer information. It won't have any other information. Product table will have only product information. Sales table will have sales information, right? So first rule is every table has a distinct purpose why they exist. Let's say we bring all the tables into one single table, right? And I know like guys from the back cannot see the screen. So one thing which you guys can do is you can join the call, or I mean, yeah, you guys can join the call and mute yourself and you can see the screen. That will do. Otherwise, you guys can go and see the recordings. Otherwise, if you guys can follow, that will be great because we don't have that class available today. Let's say we bring all of our information. So let's say we had product ID and quantities. So a product being sold and how many quantities being sold. That was one table, right? So if a customer goes into, let's say, supermarket, buys one product, one entry comes. So let's say 869 was a Cadbury, right? So Cadbury, he bought 5 quantity. Next, one more customer came. Again, he bought Cadbury and 2 quantities. 869 came two times, right? 5 and 2. Next, if we have product brand column, it will say Cadbury again, both of the times, right? Same with the product name also, whatever chocolate was the name, right? It will say the same name again and again. Product SKU will also be the same. Product SKU means that is specifically defined for that particular product, which the company can identify. So that will also remain same. Product weight will also remain same because weight will be same for both of the chocolates, right? So there are multiple duplicates in the columns which have the product related information, which is fine if your data is small. Let's say your data is only like 1,000 rows of data, which is fine. But let's say if your data is of million of rows of data, right? Then you have so many duplicates value, and if you start querying, it will take lot of time, right? That is why it is better to have. So this table is fine. The product ID and the sales or the quantity which is it is selling, it is fine. But product brand, product name, product SKU, product weight, that is all related to product. That you can keep it into a separate table, which don't have any multiple values. So you can basically, for the first two rows, it will be only one row, right? In your product table, it will be only one row. So that's why, in order to reduce the redundancy, in order to remove the duplicates, in order to increase the efficiency, we have multiple tables. And all those multiple tables serve a distinct purpose, which is to give information of specific, uh, for example, sales table is there, it will give only the sales, how many quantities are being sold or at what price. Product table will have all the information of products, like product name, description, weight, color, all those things, right? Customer table will have information only for the customers, like their age or maybe their gender or maybe their income, all those things, right? So clear with the data normalization part, right? Why we do it, at least you are clear, right? So these are all interview questions, at least for the freshers. This can come, like, I mean, they can directly ask you normalization and why we should do it. Okay. This is how you should answer it. Okay. If clear with the data normalization part, any doubts? I mean, the word only normalization means like some complicated stuff, right? It just means that all the tables should have a distinct purpose, and that's why we have different tables. So in Power BI, I haven't. So this is Power BI slide only. So I'm just using this in order to make you guys understand. So in Power BI, we'll cover this mostly in Monday session. So the data normalization part is again same in any data modeling tools. It is same in Power BI. It is same in SQL. You do it in Python. You do it in any other because tables are common in every part, right? Power BI also you import tables. SQL also you are working with tables. Python or other things are also there. There wherever tables are involved, data normalization is there. How do no? We don't do data normalization. I'm just saying there's a reason why there are different tables, right? We can bring all the information to a single table, but we should not do it because of data normalization, right? There's a reason why we opted for different tables. Okay, so if this is clear, this is your first interview question. What is data normalization? Next is there are two types of tables. One is fact and one is dimension table. So fact tables are those tables which has numerical values in it. And let's go with the definition. Fact table contain numerical values or metrics used for summarizations. Example, sales, transactions, right? All those tables are the fact tables. So I know these are all new terms, But these are just the English, right? Fact tables, dimension tables, those are English terms only. Fact tables are the tables which has numerical values in it and which you can aggregate. So for example, sales. So you go into supermarket, you buy something that is recorded right somewhere. The product ID is being sold 5 times. This 76 product ID is being sold 4 times. So this is fact table. It is showing you a fact that it has been sold this many times, right? Then there are dimension tables. Dimension tables are those which shows you information. Let's say dimension table contain descriptive attributes used for filtering or grouping. So for example, product tables. Product tables will have product names, product color, product weight, only the information of a particular thing, right? Customer table will have customer age, name, all those things that will have the information of that customer, right? Descriptive information. So now if I show you two tables, would you be able to recognize what are fact tables and what are dimension tables? So we were working with fact tables and dimension tables for the last 2 to 3 days. Let's see if you guys are able to find out that. SQL editor. Okay. So this customer table, is this a fact table or a dimension table? Dimension table because this have the descriptive information of that customer. If the customer ID is 1, his name is John, last name is Joe, age is this, country lives in is this, right? Orders table, whether it is a fact table or dimension table, fact table now, right? Because this doesn't give you information on that what was that order ID was, right? So it gives you how much was the amount of that order, right? And I'll tell you one more thing. How can you identify shippings? Whether this will be a fact table or dimension table. Fact table again. Okay. Now let's say how we can identify with one more thing. So fact table will have IDs which are there in the dimension table as well. But these IDs will be repeating also. So you see date. So okay, so in this example, if I have product ID and the quantity is there, that means that is a fact table, right? So this blue color table is a fact table. Now we have green and the orange part also. Green has the information about the date. So date is there, the day, month, year, weekday, all those things. Information related about the date, whether that will be a fact or a dimension. Dimension, right? Because that has an information about the date. It doesn't have any numerical fields, right? I mean, not any numerical field. It doesn't have a quantitative field, which is like quantities, right? Sales, data, all those things it doesn't have. It has the information about just the date. This product ID and the product information, right? This is again a dimension table, right? So one thing which you will note in dimension table is whatever ID you have is unique. Product ID, you can see all the product IDs are unique. Date, all the dates will be unique. Okay, that's the speciality of a dimension table. That first, it shows you the information, descriptive information of a particular thing in that table, and the IDs are unique. So it doesn't repeat. If it repeats, then there's no point of normalization only, right? There's a reason why it is not repeating, because if 8 is repeating again, all of these things will repeat again. So so dimension tables have IDs which are uniquely in them. So which are unique. Okay. And these IDs will be there in the fact table also. Right. So I'll tell you what those IDs are also there. So those IDs are known as primary keys and foreign keys. But for now, you guys understand what are fact tables and dimension tables, right? That's what I want you to guys to understand. This is the second interview question. What are fact and dimension tables? Okay. You can by heart the definition, but if you know already, you can explain it with the examples also. You take the examples of product table, you take the example of customer table, and then you take the example of sales table, right? Next thing, like I said, this is the third interview question, which is what are primary and foreign keys? So there are two tables, which are fact and dimension tables. Likewise, there are two keys, which are primary and foreign keys. So primary keys lies in dimension tables. Foreign key lies in fact tables. So this thing, if you want to buy hard, buy hard. But I guess if you do enough examples, you will understand which key is there and which table it is. So if you understand which table it is, if you understand which key it is very easy to understand join. So primary and foreign keys, right? Let's talk about foreign keys. So they contain multiple instances of each value and relate to primary key in dimension table. So I have the fact table here, which says on on which date what product was bought, right? And this is a fact table. So this date can be repeated. A same day, many products can be bought, right? And multiple same products can be bought on the same day. So these things can repeat. Date can also repeat. For example, 1/1/1997 is repeating, right? Same, these columns, these values of the product ID can also repeat. Is it repeating here? It's not repeating here, but these can also repeat. In the same day, same product can be bought twice, right? And these two columns are somehow connected with the dimension tables also. So you see date column is connected to the date table, right? I mean, we have not connected it yet, but I'm just saying that this date is similar to the date which we have in the date table, right? Same, likewise, product ID is also connected somehow to product lookup or the product table. This product ID is same as this product ID. Just that this product ID can repeat. This is unique. So wherever the dimension table always will consist of a primary key. The fact table will consist of a foreign key, which is connected to the dimension tables. Right? So these are the three concepts. First is normalization. Why we would need to use normalization, why we would need to have different tables, why we would need to use joins. Next is dimension and fact tables. What are the differences between facts and dimension tables? What are those? You should be able to identify just by looking at it, right? Even before looking at it, if someone will say this is a sales table, I will understand that is a fact table. If it is a customer table, I'll understand that is a dimension table. Even without looking the data also you can judge. Next thing is the primary and foreign key. These three concepts are there before we can learn anything about joins. Right, so let's identify. So we identified fact and dimension tables. Let's identify what are foreign and primary keys starting here. Uh, the customer table is fact table or dimension table? Dimension. Dimension table will have which key? Primary key. And which is the primary key in here? Customer ID. Correct? Nice. Orders is what, fact or dimension? Fact. Fact will have which key? Foreign key, right? Now, fact can have the primary key as well, but it will surely have the foreign key also, right? So in this, which is the primary key and which is the foreign key? Order ID is the primary key because it is uniquely in this table, and customer ID is the foreign key, right? So while joining, we'll use this column to join with the above table. Got the connection now, right? Let's do the same thing with shippings as well. So shipping's ID is fact or dimension? Fact. And fact will have both primaries and, I mean, it can have primary, it cannot have primary also, but it can have primary and have foreign also. So which one is the primary here? Shipping ID is the primary key here because it is uniquely defined. Now, which is the foreign key here? Customer, right? So it need not necessarily be the column names also should be same. It's not like that, right? Now, no one told you this was the customer ID, right? But because you have experience now, now you know that this is actually referring it to the customer ID, right? So this customer ID name should not, cannot be like, I mean, need not be same as to the first table. The first table has the customer underscore ID. This also had customer underscore ID, but it was totally fine if it was just a customer. It's just that we know that this column refers to the foreign key, which is there in the first table. First table is the dimension table. Primary key. It cannot have a foreign key. So a dimension table, I mean, so in a very rare scenario, that is also possible, but you will be able to identify that also. So let's say if I have uh, one more table which says country table, right? And that has a customer ID and a country. That is also a dimension table. And how we would connect this dimension table to that dimension table, that we have IDs here as well. So, I mean, that is possible, but that is also kind of a redundant, very rare, and you will get to know once that comes. But for now, for basic starters, you should know what is base dimension and fact tables and what are foreign and primary keys. So you guys understand what is foreign and primary keys, right? Okay. So before we start writing queries, right, or the joining queries, let's take one example of how the joining will work. Let's say I have one table which is, say, table one. We have table two. Table one have values 1, 1, 1. That's it. Table two have value 1, 1, 1. Okay. That's it. I mean, you don't have any other things. Table one have only one column, which has value of 1 and 1. Table two have values of 1, 1, and 1. Three values, right? Now, let's say we want to join these because consider both of them as an IDs only, right? Now we want to join them. There are multiple options we can have. We can have inner join. We can have left join. We can have right join. We can have full outer join or full join. These are the most commonly used four joins available. Okay. And how the joins will work. So I'll take one examples from each of them. This will, let's say this is a result table after joining. Okay. So inner join. Inner join means we want to get only those rows which are matching in both the tables. And how would you find which are those rows which are matching in both the tables? It Let's take any example, any table. Let's say we take the left table. Always take the left table. It's always easy to take it. Uh, One will check whether it is matching with the first row of here. It is matching, right? So result will come one here. Then this one will check with the second row. It will say again matching. And the first will check again the third. It will say matching. Then it will go to the second row in the first table. It will again check with the first row of the second table. It will again say matching. Right? And in fact, once you join, both the columns will come, right? So it's not just only one column is coming. So let's start from the starting. So this is table 1, this is table 2, and this is our result. This is column 1. This is, let's say, column 2. This is column name only, right? Column name 1, column name 2. Result table will have both the columns. So like I said, inner join will give you the results of the rows which are matching, right? And if we are matching on, because there are only one column in both of the tables, let's say we use inner join. I'll tell you the syntax afterwards, but I want you to understand the concept, how the joining is happening. So this row, this one will go to this first row here, and it will say matching, and it will return both of them. So one from the first table, one from the second table, right? So this will go into the second column, second row now, and it will still match. So it will give this one here and this one here, one and one. Fine. Likewise, if these are there, how many rows of the data in the end table we will get? 6 we will get, right? Because these two will match 3 times here. So 2 into 3, 6. So we will get this is the result we will get on the inner join. Okay. Now let's go to left join. Again, left join says all the rows from the left table, uh, all the matching rows plus the non-matching rows from the left table. So matching now you know how to find, right? Inner join was about the matching only. You know how to match the tables, how to match the rows. Left join, there is one more additional condition. So all the matching rows plus all the unmatching rows from the left table. So basically everything from the left table, yes. So table 1 is the left table and table 2 is the right table, right? So first thing is we have to get all the matching rows. The matching rows we just did it, right? With the inner join. So that was 6. This was the matching. Second condition is all the non-matching rows from the left table. So were there any non-matching? Because one was matched, this one was also matched. So there was no non-matching rows, right? Again, the answer will be 6 rows where everywhere 1, 1, 1, 1 is there. Okay. Let's say now right join. Again, this is the right table and this is the left table, right? Right join says all the matching rows plus non-matching rows from the right table, right? So we did the matching rows again, which was 1, 1, 1 everywhere for the 6 rows. Now the non-matching rows from the right table, which again, this row was also matched, this one was also matched, this one was also matched. There are no non-matching rows from the right table. Again, the result will remain same. Okay. Next is full join. Full join means all the matching rows from both the tables and all the non-matching rows from both the tables. Okay. So matching rows, again, we know these were the matching rows. Non-matching from the left table. So these both 1, 1 got matched. So there are no non-matching rows. These 3 from the right table also got matched. So there are no non-matching rows from the right table also. So for full outer join or the full join also, there was only 6 rows. So what we get with this is if everything is matching from the left table and right table, the result from all the joins remains same. So that is an universal rule. If all the things are matching, if this 1, 1 is matching with everything, then the result from all the join, inner join, left join, right join, full join remains same. But the difference happens when there are non-matching. So let's say make it little complicated now. Let's say I add 2 here. Okay, let's go again from the starting now. Inner join. Inner join, we said what was the definition? All the matching rows, right, from both the tables. So we'll start again from 1. It will match with this. 1 will match with, these 2 ones will match 3 times with these, right? So 6 will come, right? Next 2, there's no match for 2 here, right? So we won't do anything. So our result remains same until now. Only the matching rows came. Only matching rows from both the tables, right? Now difference will come when we'll do the left join. So left join, what does the left join say? All the matching rows and non-matching from the left table. Okay, so matching rows we already got from the inner join. Half part is done. All the non-matching rows from the left table. So 2 was not matched, right? So 2 will come here. And if it is known, we cannot match anything from the table 2, right? So null will come here. I'll tell you what the null is. So null basically is it does not know what it is, basically. So you cannot compare anything. So null cannot be greater than anything. So 1 can be greater than something, 2 can be greater than something, right? Null, you cannot compare it with anything. It can be anything and it can be nothing also, right? So null cannot be compared to null. So if someone asks you, is null is equal to null? No, that is false. 1 is equal to 1, but null is not is equal to null. Because null cannot be compared with anything, even with itself, right? So it does not know what it is, null. Okay, so that is our left join now. Let's see right join. I'll remove this. What is right join? All the matching rows and non-matching from the right. So all the matching rows we got here, and non-matching, there are no non-matching, right? So it will remain same, like in the join. Now comes full join. Full join means matching rows from both the tables and non-matching also from both the tables. So matching, we already have it here. Non-matching from both the tables. So let's see what is non-matching from table 1. It is 2, which is 2 here, and it will come null here. Then there are no other rows here. For table 2, there are no non-matching, right? 1 already matched. So there are no other rows. This is the answer. This is the full order. If null was here, I mean, if null was here, then we'll do null and null. I mean, next, make it more complicated. So I have, let's say, 2 and 3 here, and 1, the null is for the next example. And I have 2 here and 4 here. Let's go again with the inner join. What is the inner join? Matching join from both the tables. Okay. So what will be the first row? 1, 1. Then 1, 1 again. Then it will go to the second row, right? Because this joined with this and resulted. This joined with this and resulted. Then it will go to 1 and 2. But there's no match, right? So it won't do anything. 1 and 4 also it will go. Nothing. Now it will go 2 and 1. Nothing. 2 and 1. Nothing. 2 and 2. So it will go, oh, sorry. 2 and 2. Correct? Then 2 and 4 it will go nothing. It will go 3 and 1, nothing. 3 and 1, nothing. 3 and 2, nothing. 3 and 4, nothing. So this is your resulting table of inner join. Left join. Definitions. All the matching rows and non-matching from the left. Correct? So let's do all the matching for these already, right? And non-matching from left. Only 3. So fine, 3 and null is there, which is correct. So let's do again. 1 and 1 is matching. So this match is right. That is fine. 1 and 1 is again matching. So this came here. 1 and 2 are non-matching. But should we write 1 and null here now? Because 1 already matched, right? It matched, right? Anyhow. Correct. So we should not write 1 and null because 1 was a match. Correct. Now if we go to 2, 2 and 1 is a non-match, but it will match here 2 and 2, right? So first condition was all the matching rows first. If it matches, then only the non-matching rows. So there is only the 3 which is not matching. So it is 3 and null. Let's do the right join. Right join is the matching rows from both the tables and non-matching from right. So this is the matching, which is fine. All the rows which are non-matching from the right. So 1 was matching, that's why 1 is here. 1 was matching, 2 was also matching, 4 was not matching, right? So either we will write 4 or null or 4. Null and 4. That is the right join. Correct? Let's come to full join. All the matching rows and non-matching rows. So all the matching rows are already here. All the non-matching rows now we want. So 3 and null and 4. Getting right? Let's make it little more complicated. Let's make it null here and null here. So inner join again. So all the matching rows. So all the matching rows, that means 1, 1 was matched, 1, 1 came here. 1, 1 again. So 1, 1 again came here. 2, 2. So 2, 2 came here. 2 and 4 are not matching. Correct? 2 and null are also not matching. Correct? 3, 1 not matching. 3, 1 not matching. 3, 2 not matching. 3, 4 not matching. 3 null not matching. Now comes null. So null 1 not matching, not matching, not matching, not matching. So should we write null and null now? No, right? Because I said null cannot be compared. Correct? So we won't write null for the inner join. But let's come to left join now. This will be interesting. All the matching rows. So the result from the inner join we already have. All the non-matching from the left table. So 3 and null. Anything else? Why this null won't come? But it is still not matching, right? So it will come here. Null and null. So this null is not coming from here. It is not coming here because it is not matching. So this null doesn't have any matching values from here. Right? So this null comes here. And this is the null which was coming for the last 3 steps also, right? If it's not matching, then it is null. Got it? Let's go with the right join. So right join matching rows are already here. Non-matching from the right. So null and 4 and null and null. Got it? Because this null comes here and it doesn't have any matching null. So null comes here. Interesting, right? Let's do full join now. So matching rows already I have. Non-matching from left and then non-matching from right. So non-matching from left is 3 and null and null and null. Null and 4. Null and null. So that is the concept of all the joins you have. Okay. Now this, we have done it only on one column. This can be done on multiple columns as well. Okay. The other columns which I will add, that basically have no value. The value which have is only on the columns which we are joining. So we are joining only on these 2 columns, right? I can add other columns also. It will just come as a third column here. Let's take one more example. Let's build our own data. So let's say we have our table, which is customer table, right? It has 2 columns in it now. One is ID, one is name of that customer. ID is 1, 2, 3, 4. I make it easy. Name is, let's say, Ashish, Prashant. These are my friends' name. And we have sales table. Sales table will have a transaction ID. Let's say we have a transaction ID, which can be something, let's say 1000, 1001, 1002, 1003, 1004, something like this. And then we have customer ID, which will be, let's say 1, 2, 3, 3, and 4, like this. And then the sales, right? So on that transaction, what was the sale? Let's say I do 200. This was the sales. This is our one table. This is our another table. And let's say now we want to do result table, right? And I want to bring all the columns from all the tables, right? I'll come again on those stuff. I have to make it smaller. Okay. So this is the result which I want to create, right? So whenever you join two tables, there is extra piece of information which you are bringing to your result table. The table is getting wider. So right now, before the table one had one column, table two had one column, but your result table had two columns, right? So whenever you join, you add the columns to your table or the result table. So yes, in this, which is the dimension table and fact table? Customer table is dimension table. This table is fact table. Okay. Let's consider this as a left table now and this as a right table. What are the keys? So fact table will have what keys? Foreign keys, and it can have primary also. Which is primary and foreign in these? Transaction ID is primary key. Customer ID is foreign key. Okay. In this dimension table will have what? Primary or foreign? Primary key. So customer or the ID is the primary key. Now I want to make this type of table which will have all the columns from the left table also, right table also. Okay. So transaction ID, customer sales from the sales table, ID and name from the right table. Transaction ID is the primary key. Okay. This is only for a specific transaction, right? This ID won't repeat again. Okay. Let's do inner join on ID of a customer, right? Which is this column and this column. We want to do inner join on the customer ID. So in the previous steps, we were joining on because there was only one column. We were joining on these two columns, right? Now I'm saying forget about the other columns. We just want to join on these two. And inner join means inner join. Yes, all the matching rows from both the tables. So if I specify the columns on which I have to join, which is customer ID, it will go 1 and 1, right? So it will tell, okay, so customer ID. Okay. The customer ID is 1 and the ID is also 1. It matches. And once it matches, it gives the information of those row also. So 1 and 1 matches. It said transaction ID was what? 1000. 1000 comes here. Sales was what? 100. Name was what? Ashish. That is the first row which we matched. Next row which is matching is, so it will go to the second row. 1 and 2 are not matching. Gone. 1 and 3 are not matching. Gone. Then 2 and 1 not matching. 2 and 2 are matching. Correct. So it will say 2 here and ID also 2. And it will take the information of that column as well, which is transaction ID is 1001, sales is 200, name is Prashant. Got it? Then again 2 comes to 3, no match. 3 comes to 1, no match. 3 comes to 2, no match. 3 comes to 3, match is there. So 3 and 3. Now it gives the information of that particular row. So it is 1002. Sales is 300. And the name is Abhishek. Fine. Now this, we are on this 3, right? This 3 matches with this 3, we got the result. Now this 3 comes again. 3 matches with 1, no. 3 matches with 2, no. 3 matches with 3 again, right? So again 3 and 3 will come. But in here, instead of 1002 now, 1003 will come because we were on the this row, right? 1003. This is 400. And again Abhishek only will come. Correct? So the fourth one I'll do quickly. So there are no any matching for the fourth one, right? So the inner join will result in this table. Correct? If it was the left table, matching is fine. This is the matching one. All the results from the non-matching ones. Correct? So non-matching means customer ID is 4 here. The ID from here will be null. So this is 1004. Sales was 500. ID was null, and again here also null will come. Got it? Why null both time comes? So it is not matching. That's why null for the customer ID. And customer ID, if it is null, they have, there's no value corresponding to null anyhow, right? So this also is null. Okay. Right table, if you want to join, all the matching again comes until here, and non-matching from the right table, which is nothing, right? Full outer join, matching is there, and the non-matching from both of them. So again, this will come. So at least you got the gist out of it. At least before writing the table only, you should visualize what is the table you are about to get, right? And then writing the SQL query is easy part, because that is again and again we'll be writing the same and same thing. Okay, so let's do an example of writing a query. So I'll remove whatever we have and select. We'll select from customers. So it's basic. So most probably, most of the time, your dimension table are the left tables, and your your fact table are the left table, and your dimension table are the right table. So whatever you define from in the from, are the fact tables, because fact tables are very big in nature, and there only you would need to have the additional columns. There's no point of bringing values of sales of John here. If I bring the name of John after the customer ID, then it will become sense, right? So just a handoff rule. I mean, it's not a universal rule. You can join left table to right or right table to left. But usually, most of the time, what will be happening is in the from table, you will define your fact table, right? So in this from, we have to either provide orders or shippings. Let's say we provide orders, right? Next statement is join. And what type of join you want to do? Let's say we do inner join. Okay. Inner join. Until here, now it's perfectly fine. After inner join, again, you have to provide one table name, which is the right table. The left table you have already provided in the from, which is the fact table. And inner join, you will provide a dimension table from which you want to bring the information. So the end result would be I want these 4 columns and one more column of customer name, right? So I want 5 columns at the end. So I want to add one more column after this. So inner join customers. Okay. Now you have told SQL that this is the left table, this is the right table, but you have not told SQL that which column you have to join. Because in the example which I showed you, I told you guys that this is the ID and this is the customer ID on which you have to join. But SQL is also a machine, right? It cannot configure it itself. You have to tell SQL on which column you have to join, right? So the syntax is on, and you have to specify both the columns, right? So in this, from the orders table, we have which column? Customer ID, right? And from the customer table, we also have customer ID. So there should be an option to tell SQL that one column is coming from the orders table and one column is coming from the customer table. So one thing which we can do for the basic starting is orders dot customer ID, which will tell that this is the customer ID which you have to take from the orders table and is equal to customers dot customer ID. This is the column. Aliases which we can also use, and that is the next step which I will tell you, right? So this will tell SQL that from orders, you take customer ID, which is this column. And from customer, also you take customer ID, which is this column. On the basis of this and this column, you do the joining, which we were doing it for like last half an hour, we are doing the same thing, right? So once the from is run, once the inner join is run, once the on is run, then the select will run. And inside select, you can specify which all columns you want, right? So let's say I want all the columns from orders. So if I want all the columns from the orders, if I press star, it will bring all the columns from all the tables. So I want only, so let's say, well, let's start with star first. So I select star and run. So you see order ID, item, amount, customer ID, order ID, item, amount, customer ID, customer ID, first name, last name, customer ID, first name, last name, and there are age and country also. All the columns from both the tables came. And how did it do the joining? Why only 5 rows came? Okay. yeah. So for all, if I'm doing inner join, so 4 is joining with the 4 here, and this 4 is also joining with the 4 here. Correct. That's why there are two 4s here. But it is like too many columns, right? So to make it simple, let's say I want to take order ID, customer ID from the orders table, only those two things, and customer ID and first name from the first table. So how we can do it? Again, like we did it here, right? To specify a column name, we can specify same thing here as well. So let's say orders dot order ID, comma, customers dot customer ID. Let's say we take only those two columns. And if I run now, let's see how it comes, how it came like this. So first we are doing it on customer ID and the customer ID, right? So these two columns we are joining. The customer ID from the orders and the customer ID from the customer table. First row which will add is 4 won't match with 1, 4 won't match with 2, 4 will not match with 3, but 4 will match with 4, right? Customer ID 4 comes and the order ID was 1 with on that. Order ID 1 also came. Next row it will go here because this is the left table, right? 4 again will match only with the 4 here. So 4 comes here and order ID was 2 for that. So order ID 2 came here. Okay. 3 will match with 3. 3 comes here and the order ID was also 3. So 3 comes here as well. 1 will match with 1 here. And so 1 comes here and order ID was 4. So order ID 4 comes here. 2 will match with 2 here and 2 comes here and the order ID was 5 for that and order ID 5 came here. So you see here 5 was there, right? So there's no 5 matching happened when we do inner join. And that's why 5 was removed from the resulting table. So in fact, we should bring, instead of order ID, we should bring customer ID also here in just to make it more simpler. So this is what is happening. Okay, so 4, 4, 3, 1, 2 came, but 5 did not come. So I guess you guys are fine with joinings, but only the syntax part is the thing which will require a little bit effort. And that will come only once you practice more and more questions, right? Only one thing which I'll cover more now is we can provide aliases. So every time you have to write orders dot, orders dot. If there are 5 columns which you want to bring from orders, you have to write every time so orders dot, those big columns names, right? So what you can do is you can provide aliases there as well. You can tell SQL that from next time onwards, so if I provide AS, oh, right. So from next time, I won't be telling you that this is the orders table. I will tell you only that this is O table, right? To make it simpler for me. Inner join customers also I can tell. Next time I won't be telling you this is a customers table. I will be telling you this is a C table. Okay. So after these two statement runs, wherever you want to replace orders with O, you can replace. Wherever you want to replace customers with C, you can replace. So I can replace orders by O here. Again, I can replace customers with C here, orders with O here, customers with C here. Okay. If I run, the results will be same. Okay. So the only thing which we added in our queries, which we were already writing, right, are joins. So from remains same. Select almost remains same only because we are still selecting columns, just that we have the opportunity or we have the option to select from both the tables now. We were selecting only from one table, so we were not giving aliases. We were not telling which column you have to select this column, right? Which from which table you have to select this column. But now we have two tables, so we have to tell SQL that which column from which table you have to select. So there's only slight modification which we did in select, so which is fine. From remains same as it is. Joins also we provide table name. So here also table name we have to provide. And on a condition. So on key values, key on keys. Okay. Same how, I mean, you can do left also here. You can do right join also here. You can do full join also here. We'll practice more questions on this uh, joins, but at least I have covered four of the major interview questions which are asked generally. First is what is normalization? What do you mean by normalization? It can come into different languages also. The interviewer might not ask you what is normalization. It can ask you why we need to have why we need to have multiple tables, how to improve the efficiency of your tables. Why cannot we bring all the data into one single table? So all that answer is related to normalization. Okay. If you speak one word only, that non because of normalization, that is correct answer. Now you can explain also. Next is fact and dimension tables. What are fact and dimension tables? Right? All the tables which have some numerical value in it, which have the transaction sales, all those types of information, those are fact tables. All the tables which are giving the descriptive information about a particular thing, those are dimension tables. Then next one which I discussed was the primary and foreign keys. The dimension table contains primary key, fact tables contain foreign keys. Okay, foreign keys can repeat, dimension in primary keys cannot repeat. Okay, and foreign keys are somehow connected to the primary key in the dimension table. These are three questions. Fourth question, which was hands-on, like how many rows would be there, right? So interviewer can share his or her screen, can just type in one bunch of ones in both of the tables and can tell you like what will be the resulting table if I do left join, full join, right join, left join. What will be the number of rows, right? Then you can tell by this approach, right? So at least four questions are covered, and joining is the syntax which I showed you. It gets as complicated as it is now. So there are no complicated things in inner join as well. So this is the most complicated thing which you'll see for the join. Okay. So this is something which you have to buy hard, but I guess once you do enough practice, then this will be your second nature only. Okay. From is fine, then you have to do joinings and on some columns which are common in both the tables. Okay. So somewhat clear, right? What is join? Any doubts if you have, I am available for next half an hour and then we'll continue. Today's Friday, right? We'll continue from Monday onwards. And select whatever you want to select. I mean, so if I want to select only just the customer ID from orders, I can select that also. Sometimes full join won't work, full outer join will work. Only the syntax part is different in some of the languages. Customer ID and order ID both from order script. Yes. Yes. If you want to select everything from orders ID, so O dot star you can put. That means everything from O table. Correct? First we will what? Yes. So good question. So there, this is also related to order of execution. So let's say if we take this query, right? So this is an important concept again. If we write select O dot star, would SQL run selects O dot star first or from first? From first, right? So whenever SQL will start running, it will start running from. So it doesn't know what O is here until now. From from when it runs, it will say orders as O. Then it will run the third line, this will run the fourth line, and then it will run the select. Then by then that time it will know, right, what is O. Yes. So that's how, like if we were running from the first statement, select O star, what is O then? It should throw error, right? But it won't throw error because it is running from and then it is going to select at the very end. Okay, yeah, that's it. We'll meet on Monday and I'll share the recordings.